Hey Tom, I had a customer call me asking about installing a strain gauge on concrete application. Can you go over the steps?
I'd be happy to, Collin. The first step, and we've already achieved this because it's kind of dirty to demonstrate in the laboratory, we will take the concrete specimen and I'll pressure wash it. I'm removing all the gross organic contaminants, that mud and the extra concrete and that sort of thing. Having completed that and allowing it to fully dry, and by the way, the AE10 and GA2, the adhesives we'll be using for the pre-coat, are moisture sensitive. So we've dried the surface, and then we're going to take a standard wire brush, and we're going to work away the loose contamination. You'll see that the color lightly changes, and I'm getting concrete dirt all over you. Nothing personal. Once we've completed the abrasion to get rid of the gross contamination, and I typically will either use compressed air or something like that, but in the fact that we don't have any compressed air, I'm just going to take it and shake it, taking the loose contamination off of it. Then I'm going to locate the conditioner A, the mild phosphoric acid solution. And by the way, we're going to prepare the surface here for both GA61, or excuse me, AE10 and GA2. The AE10 being the clear material and GA2 being black and having nearly the same performance. So the first step in surface preparation after getting the loose contamination out is to take conditioner A and we scrub the surface. You'll notice that it kind of foams up just a little bit. That's the mild phosphoric acid solution reacting with the concrete. I'm going to do that same thing here in the location where I'm going to do the GA2. Again, we're basically just moistening the surface, getting all the loose contamination away from it. And this is the conditioner A. Having completed that step, I'll take a warm air blower, and this might take a little while, and I will warm the surface, driving that conditioner A off. And this could take a couple of minutes. We've now just about completed the drying step. You'll notice that the moisture the surface becomes dark when it's wet and dries when it's, or lighter when it's dry. Got both of these sections nicely cleaned and dried. The next step is locate the neutralizer 5A, the blue tip bottle, and we're going to do that very same scrubbing step. I'm going to wet a cotton or gauze sponge with the neutralizer 5A, and then I'm going to scrub the surface. This is going to take the conditioner A pH and neutralize it, or make it slightly basic. And it's also going to again remove further the organic components because there's a little bit of detergent in the neutralizer 5A. Just wanting to get the surface to the proper pH so that the epoxy systems will bond properly. Having completed the wet scrubbing with the neutralizer 5A, again I'll take a warm air blower and drive off the excess moisture. What this has done is gotten rid of the organic components and gotten rid of any of the surface contamination, and now we're using the neutralizer 5A to bring the pH of the surface back to nominally neutral or slightly basic. And we'll use the warm air blower to drive off the excess moisture that we've produced. We're now completing the drying of the neutralizer 5A. You're making sure you drive all the moisture off. The concrete will be dark colored if you still have moisture left, and it'll become a lighter color once you've finished. And it appears that we pretty much finished our drying with the warm air blower. The next step, because the concrete is so rough, we need to put down a pre-coat. Now I'm going to demonstrate the pre-coat with both AE10 and GA2. The major difference between the two: the GA2, the resin has a filler in it that's black. The AE10, on the other hand, is nearly clear, and will go on a fairly clear. There are those who like the GA2 because as they're beginning to abrade the surface to get back to the apparent material, the GA2 goes from a black color to a gray right before you abrade through it. The next step will be to mix the two adhesive systems. Collin and I have now dispensed the curing agent into the resin jar of both the AE10 and the GA2, and we're going to stir this for a full 5 minutes. That allows the two materials to get ingested very thoroughly and evenly distribute the exothermic reaction. Note we're both holding it with the top edge of the jar. We're not trying to add any heat. If I were to grab it with my fist, I would be shortening the pot life of this material. We definitely don't want to shorten the pot life. I've now completed the mix cycle of my AE10 filler that I'm going to use to fill the surface. If we were to try and bond a strain gauge directly to this concrete, the roughness of the surface would probably damage or change the resistance of the strain gauge. I need to determine how much of an area I need to cover. I've got a 2-inch long strain gauge here, so I'll probably cover between 4 and 5 inches on the concrete specimen. I'll just take the AE10 and I'll pour a little bead of it down the lengthwise of the beam or the concrete, about the length that I'm hoping to make it, somewhere between 3 and 4 inches. And once I've got what I believe to be the right amount, I'll take my stirring rod and I'll spread it out evenly. What I'm trying to do is make sure that this is filling the pores of the concrete and is sufficiently wide and long so that my gauge will land into it. Having completed that pre-coat, or at least the gross amount of the pre-coat, I'm now going to take a piece of the PCT 2M tape, about 7 or 8 inches long, much longer than the pre-coat that I've done. And how's it curls up and makes a mess of itself. All right, proving once again, even Tom Rummage can curl up the tape. Now I've got the tape uncurled. And to make a relatively flat section that's relatively thin, I'm going to take this and I'm going to squeegee it back and forth just a little bit and then tack it into position. What this is doing is squeezing out a little bit of the excess AE10 so I don't have quite so much to sand away when I come back after the fact. And I'm going to lightly run across, and note that I've got the excess adhesive that was pushing out on the edges. I've gotten rid of that. And now I'll wait for the full cure time of the AE10. Now Collin is going to demonstrate the GA2. The practice is identical to that of the AE10, only this material is much more a darker color and slightly more viscous. So take a little bead of the material, wring it out about 4 inches or so long. That's plenty of the material. You'll have more than you know once you get that spread out. I'll take the AE10, the GA2. This is Collin's first attempt at doing this, and it looks like he may have added a little excess of adhesive. That's okay though, we can always get rid of it. Better to have too much than not enough and have a starved bond line when you're trying to pre-coat. Looks like you got her there, Collin.
Okay.
And since Collin has a relatively large puddle of this material down on this end, to avoid it getting all over things, I'm going to absorb the excess. Collin will do that same step that I did. He'll take the PCT 2M tape and squeegee it back and forth a little bit, sawing it a little bit and pressing down. Once he's comfortable that he's saturated the tape and sawed it through, he'll now take a gauze sponge and wipe away the excess on the outside edges. You're not pressing hard, you're not trying to get rid of the adhesive. And so now these two materials are now set for the pre-coat. We would allow this to, if we're doing it at room temperature, it'd take a minimum of 24 hours to cure. If we put it into an oven, which we're probably going to do, it should take no more than an hour or so. Okay, Collin, it appears that our pre-coat of both the AE10 and the GA2 has finally cured. So we're going to remove the tape that we put down to limit the adhesive, PCT 2M tape. And you look at that and it looks like it's pretty well coated, fairly uniform. We don't have any voids or discontinuous behavior. I'm going to take 220 grit silicon carbide abrasive paper and make a little sanding block. And I'm going to abrade with 220 grit silicon carbide abrasive paper. And you'll notice the high spots are being knocked off and I'm getting close to a uniform surface. I'll keep doing that until the whole surface appears to be like this kind of darkened color. Now the silicon carbide abrasive paper loads up fairly quickly, and if I had the opportunity I'd wet abrade, but the problem is with the concrete it takes so long to dry out afterwards. We don't want that to happen. So put a fresh piece of silicon carbide abrasive paper and keep sanding until I get a nice uniform surface. You'll note that some of the concrete is coming through. If you look here, the concrete is beginning to show through, but we're getting a nice uniform surface to bond to. I'll do this a couple of more times. Get us down to the right surface finish and surface plane, if you will. Okay, we're pretty much now have a uniform color. We've gotten a uniform surface thickness. We can go ahead and do the other AE10 if you'd like, or we can go ahead and finish the M-Bond GA2. I'm inclined to go ahead with the surface preparation of the AE10 simply because of the close proximity of the two to one another. So I'm now going to begin that same abrasion process with the AE10. And this one's a little thinner because I used a little less adhesive, and so it will take a little less abrasion to get to that nice uniform surface. Rotate the paper one more time. And the reason I'm using this sanding block, if you will, is to keep it nice and uniform thickness. At least the adhesive layer that I'm taking loose. Okay, we've got pretty much a fair surface on both of those now, ready for bonding. So we're going to go ahead and prepare and bond the AE10 first, and then we'll prepare and bond the GA2. So in preparation for that, we'll take our glass plate, some neutralizer 5A, the Bo Peep ammonia solution, drop a couple of drops onto the glass plate to clean it. Clean dry gauze sponge folded into quarters, and I'm going to clean the surface of this glass plate. Now because of the pre-attached lead wires, you have to be careful, you'll drop them. We got to be careful because the lead wire is fairly robust in comparison to the gauge itself. So the first thing we'll do is we'll slide it out of the sleeve and then laying it down on top of the glass, and this can get to be a little tricky because of the wire. Kind of want to remove the strain relief there. Then I'll just basically slide it out of the acetate folder. And now Collin will take some of the PCT 2M tape. I'm going to take a piece about 6-7 inches long. He's discarding the first few inches because it may be dirty. He'll stretch it so it doesn't curl up so much. And then he'll apply that over the surface of the gauge, starting at one end and then lightly with his thumb or forefinger, and train the gauge underneath the tape. Having done that, he's going to make a little handle so we can easily remove it. We're now prepped with the gauge. We need to mix the GA2 like we did before for the pre-coat. And Collin will go ahead and take the pipette and dispense the proper amount of material. Going to the type 10 line. That looks good. Going to dispense that in the center of his jar. We'll immediately cap the curing agent because it is hygroscopic and will absorb moisture, which would tend to make it less functional. Before you put your sleeve into that resin. And now he's going to mix for 5 full minutes. While Collin is finishing mixing the GA2 adhesive, I'm going to demonstrate how we will take this 20 CLW gauge and transfer it over to the place where we're going to bond it. Now, as it is an unbonded gauge, we want to lift it a shallow angle until we are beyond the gauge, and then it doesn't really matter much. I'm now going to position the gauge over the alignment marks that I've made on the part and just squeegee it into position. I have prepared here my silicon gum pad and aluminum backing plate, and we'll be putting weights on top of this in order to distribute the load. Collin has finished his 5 minutes of mix, and now what we're going to do is apply the adhesive. Now he uses a dry gauze sponge to clean off the stirring rod because we don't want any unmixed curing agent or resin to get onto the table and or surface. Let's do a little quick maintenance. That's going to be a mark. All right. Now, because we've now finished mixing it, we're going to expose the bonding surface of the gauge, peeling it up at a shallow angle until I get beyond the gauge and into the lead wire system, and I'll peel it back. And what Collin's going to do is he's going to dip the stirring rod into the center of the jar. Bring the jar over so it doesn't drip on the table. And let 2 drops drop off of the stirring rod, not critical. And then he'll wet the backing of the gauge with the adhesive. He's smearing it completely down the length of it. The important thing is to make sure that the entire surface of the backing of the gauge, the bonding surface, is wetted. He'll then get another drop of the adhesive, and this time he probably only let 1 drop off. And then he'll coat the area where the gauge is going to land. We want to make sure we get a good coating of adhesive. And if there's any discontinuous behavior, it's filling those little voids that are there. Okay. Then we take a gauze sponge, fold it into quarters, fold the gauge back over onto itself, and then lightly squeegee it into position. And we're relying on the end of the tape out here to hold it in position. And then we will take our silicon gum pad and aluminum backing plate that covers the entire gauge and lead wire connection here. And then we'll apply his weight. It's a total of 10 pounds. Turn it upside down. So we can get here and here. 20, right? Now your clamping is limited by your imagination and your skill to balance. So at this point we've got a nice even clamping pressure, a total of 20 pounds of pressure over the square area here. I think Collin calculated this to be how much?
The 1.875.
So we're calling it 2 square inches more or less, and we got 20 pounds on here, so that's going to be nominally about 10 psi of clamping pressure. The GA2 takes between 5 and 20, so we're right in the middle of the range. And now we have to wait. We have to wait the full 6 hours for room temperature cure. Generally, what we would recommend, however, is to cure it overnight. All right, so Collin, we've left this clamped up overnight. We put the adhesive down and spread it out and got it all clamped up. It should be properly cured, so the first thing we're going to do is we're going to remove our weight. The silicone gum pad and aluminum backing plate, which we'll reuse. And then we want to do a little quick visual inspection, and I don't see anything really horribly wrong. I might have seen a little speck of dust or debris right here, but it doesn't look like it's going to have a significant effect. So we got two choices. We can either pull the tape this way or go this way. I generally prefer to start on the wire end because I can hold the wire down and keep it strain relieved. So I'm going to slowly pull it 180 degrees back on itself. And that pretty much completes the insulation with the GA2. Now, after we've finished this, we're going to go ahead and do the AE10 also. But once we completed this, we would do an environmental protection commensurate with the environment we're going to expose it to. We might use the GA2 as an environmental protection. We might use M-Coat J. We might use M-Coat F. There's a number of different options that you could use depending upon what it's going to be exposed to. So we've demonstrated the bonding with the GA2. We're going to now demonstrate the AE10 bonding, and something that we observed from the first bonding was there are a few pieces of debris, not significant, probably wouldn't affect the performance of the gauge, but I want to get rid of that. And a way to do that is to take either isopropyl alcohol, and I'm going to use our rosin solvent, which is isopropyl alcohol and toluene, and I'll lightly wipe that across it, picking up the leftover lint debris and or maybe some dirt or dust from the concrete. The rosin solvent evaporates very, very quickly, so I don't have to worry about it being residual there. It'll be gone in about a minute or so. In order to keep from spilling it, I'm going to put the cap back on the rosin solvent. And now, I'm going to have Collin go ahead and mix the AE10. We have the type 10 curing agent, the resin, a pipette, and a stirring rod. And as with typical with the AE resin, you go ahead and open up the cap and throw it away. You're not going to keep that. Collin is dispensing to the number 10 line for the AE10. Put that into the center of the resin jar. Note he capped up the AE10 curing agent. It's very hygroscopic and we don't want to have moisture absorbed in that material, just like the GA2 material. He's checking his watch, so we're going to do a 5-minute mix cycle. We'll come back as soon as he's finished the mix. All right, Collin has finished the 5-minute mix cycle for the AE10 curing agent resin, and that's because it's an exothermic reaction and we want to make sure it gets properly kicked off and on its way before we start spreading it out. We're going to take the 20 CLW gauge. This is a C2A series of gauge that has 10 feet of vinyl insulated lead wire pre-attached. And the 2-inch version of it, the 20 CLW, is a popular item for the concrete structures because you want to average over a fairly significant area. You don't want to have a small strain gauge. The civil engineering people like that. So we're now going to chemically clean our glass plate, our layout station. A couple of drops of neutralizer 5A, and I'm going to scrub with the gauze sponge. Now this is a 2-man operation because of the length of the gauge. I'm going to slide the cover off the gauge and then slide the gauge out of the acetate folder. And I'm going to ask Collin to pull a strip of the tape off about 2 inches and throw it away. We don't want to have that contamination there. And then a long enough strip to be able to easily transfer this gauge over to the concrete block. Note the static electricity. You want to put your other arm out. You want to block, don't want to block the camera. Sean will edit this out.
Yeah.
He's now pulled off a strip of tape. He'll tug it to keep it from curling up, and then he's going to place that over the top of the gauge and wire combination, starting at the wire end, and then lightly squeegee forward until he entrains the entire gauge. Having completed that, he's going to lift at a shallow angle, until he gets beyond the gauge. Being careful, these lead wires are a little bit fragile. You don't want to damage them on the process. So now that he's got it beyond there, he's just going to pick everything up. We're now going to move it over and prepare where we're going to put it on the part. Okay. Now we need to expose the bonding surface of the strain gauge, just like we did on all of our strain gauges. We're going to lift it again at a shallow angle until we get beyond the gauge, and then peel it back on itself. Now Collin is going to wet both the backing of the gauge and the surface where the gauge is going to be bonded. If these are not thoroughly wetted, you might have voids or discontinuous bond line, and you want to avoid that. So on the gauge, you'll let 2 drops drop off the stirring rod, and then we'll squeegee it on, making sure he wets the surface of that gauge contiguously all the way up on the grid. Want to see it turn nice and shiny. That says it's wetted. And he's done a pretty good job there. Then he's going to take another drop. He's not going to drop but 1 drop off because he needs the volume now. And he's going to put that in the area where the gauge is going to land. He's going to wet the surface of the precoded concrete, and this has been pre-coated with the AE10. Making sure he's got plenty of the adhesive there. I don't see any reason why we would be concerned, and we're now going to reposition the gauge onto the part, take a gauze sponge, fold it into quarters, and lightly press it into place. We're not relying on that for clamping pressure, and then we're going to take our silicon gum pad aluminum backing plate, which is cut and sized so that we're going to get nominally around 10 psi of clamping pressure when we apply a 10-pound weight. And we've located a single 10-pound weight, or 20-pound weight this time, 20-pound weight. So it's 2 square inches, and we're going to have 10 psi. And we're going to put this over the top of that silicon gum pad aluminum backing plate, doing the balancing act. Until it's evenly clamped. Because of the silicon gum pad has a little compliance, it told me whether it's balanced or not, or whether I'm evenly clamping, because the silicon would give this way and give that way until it gives us an even clamping pressure. We're going to leave this clamped up overnight. The minimum cure time at room temperature, 75 degrees Fahrenheit, is 6 hours. But because this is a concrete structure and it's rather cool, and we want to be sure that it properly cures, we're going to let this cure overnight. Okay, Collin, we've finished our clamping and curing of the AE10 material, so I'm going to go ahead and take this clamping off, the 10-pound weight, 20-pound weight. We'll remove the silicon gum pad and aluminum backing plate. And like we do with every strain gauge installation, we're going to take the tape and pull it 180 degrees back on itself. That puts the adhesive into shear when it's most strong. Once we get past the wires, I'll put my finger down there just in case there's a little tug. Now expose the bonding surface of both the GA2 and the AE10 adhered gauges for concrete. Now we need to put down an environmental protection. Now on the AE10 material, just because we could use it as the environmental protection, we're going to use AE10 as the environmental protection also. And Collin is going to mix up JA2. It's a polysulfide material, an alternate protection for the same kind of setup. So in the AE10, again, as you've seen before, I'm going to open up the resin jar, open up the curing agent, draw up to the line 10, dispense that into the center of the AE10 jar. And then I'm going to begin mixing it. Notice I'm holding the top of the jar by the top of the rim so I don't add heat to it, because this will shorten its pot life. Now this requires a minimum of 5 minutes of mixing time. That's so that the exothermic reaction that's going to occur here is evenly distributed, so you don't get a hot spot where it cures early in the middle. Collin is going to go ahead and begin the mixing of the JA2, the polysulfide epoxy material. You'll notice he's going to take the black rod and he's going to press the curing agent into the resin, and then he's going to take the plunger and push down in and then screw it into the little paddle that's inside. And once that starts to turn the paddle on the inside, he's going to pull it back and forth as he's mixing it, so he thoroughly mixes the material. There's a little paddle wheel in there that he's pulling back and forth and rotating at the same time. And what we're hoping to find is that when he finishes mixing it, we have this nice uniform gray-brown color. And in my case, we have 5 minutes worth of mix time, and we're going to have the AE10 as a relatively clear material. So we've now completed the mix cycle for both the AE10 and the JA2. The AE10 has a much shorter pot life, so we're going to go ahead and install that first, and then Collin's going to show you how to do the JA. Because this can be used directly over exposed electrical connections, I basically just pull it out and smear it along the length of the gauge, and about a ½ inch on either side of it. We want to make sure we got a fairly substantial area covered, and it's a good thick coating of the adhesive. And we also want to get up here to the transition of the lead wire, so we keep that completely protected also. The point here is we're going to keep moisture and dust and debris and dirt out of the gauge site. So we're basically just wiping it over the entire surface, trying to make it fairly even. I'm spreading it out a little wider than the gauge so it covers it completely. And I'm looking for any air bubbles or things that might have a discontinuous behavior. And that pretty much covers putting down the AE10. Notice I'm trying to encase this junction very carefully, trying to get the air bubbles out of it, because that'll be a place where the moisture could get in. Now Collin is going to demonstrate the installation of the JA2. First, he's going to dispense it by pressing the diaphragm from the back side, and he's going to make a nice even bead of that. The important thing to look for and make sure you've mixed it well enough is that it has a nice uniform gray color. If it were not a uniform color, you might not have mixed it well enough. Now, because the JA is conductive to ground, we want to cover the exposed electrical connections of the strain gauge with a piece of Teflon film that Collin has in his hand. He's going to strip away the backing, and then he's going to put that over the top of the electrical connections. Now this is an encapsulated gauge, so all he has to cover is the actual electrical connections themselves. If it were an open face gauge, this piece of tape would extend all the way along the length of the gauge. He's now going to take a spatula. He's going to take off a chunk of it, and then he'll just begin smearing it over the top of the gauge, and it's the consistency of creamy peanut butter, maybe a little bit less viscous. He wants to get a layer that's not too thick but not too thin. Somewhere in the neighborhood of about 1/8 of an inch is where you're shooting for. And he wants that to extend about 1/4 of an inch to 1/2 inch beyond the open edges of any of the gauges and or this tape. I want to make sure the tape is completely encased. Either that or the moisture or the environment would come in through the edge of the tape. I take just a little bit more over here on the tape side. The JA has a pot life of nominally about 1.5 hours, so he's got plenty of time to work with it. But it's a good idea to go ahead and get it done as quickly as practical, so in case you do run into a pot life issue, you're not going to run into problems. He'll do the same thing I did with the AE10. He'll completely entrain and encase that junction, because there's another potential place for the environment to get into the gauge. You just kind of work it in and out and around the lead wire and over the top of that shrink tubing junction. Now we wait for the cure of the AE10 and or the JA material. The AE10 will cure to full cure in 6 hours at room temperature, but we prefer to cure it overnight for 24 hours. The JA requires 24 hours of cure no matter what. Both will be tack free in probably an hour or two, but you want to let it completely cure before you put it in the environment.